Yes. Hi, my name is Donna Wunema. I'm here to present the Village Telco project. First question is, who am I? First, I'm a software engineer. I'm expert in wireless systems, telecom systems, and embedded software. I'm also the founder and CTO of Wireless Dialogue. I'll come to that later. The main focus of this presentation is to talk about the Village Telco project. First question is, what is the Village Telco? Effectively, the Village Telco is a low-cost community telephone network. What that means is that, I'm not sure if you guys are aware of the wireless mesh networking. With wireless mesh networking, effectively, every node becomes a gateway and a router, as well as an access point. What the Village Telco does is take that concept and integrate in an analog telephone adapter. So you can effectively plug in an analog device and an analog telephone and make phone calls. The key point of the project is sets up in minutes. So you don't have to be a bash script wizard to set one up. And also, one of the key questions was that, why do you need a Village Telco? The main problem in developing countries is that for access, you need mobile phone towers. In Europe, we're blessed with the fact that there are copper networks and they're actually fiber networks. In emerging countries, the government would not actually invest in copper networks, so it's left to private companies to invest. Now, us, obviously, looking at the bottom line, they're more interested in getting the most users onto the network as possible, so they're only focused on urban areas. And I've mentioned before, it's a wireless mesh technology. I have a sample for those who want to have a look at a unit. At the moment, it's around $100 per unit, but that price will go down over time. The question is, why? I'm not sure if you guys are aware of the mobile telephone network in the mobile telephone business, effectively, in developing countries, places like India and sub-Saharan Africa. Effectively, calls are very expensive. The rural parts of the world is basically just been ignored, effectively, because they're subsistence farmers. They cannot actually buy a mobile phone, or even if they do get a mobile phone, they can't actually afford the tariff prices. So effectively, you said, well, how do we then enable these guys to become connected? And obviously, we can not only use it for developing developing countries, we can also use it for community wireless, like the Free Funk in Berlin. The features of it, basically, it's locally owned, no spectrum license. It uses the open, the same as a wireless mesh. It uses 2.4 gigahertz or the 5 gigahertz spectrum. Everything about the whole architecture is actually open sourced, and I'll come to that later. And obviously, the focus on rapid deployment. And this is the constituent parts. We basically have a billing server, and within the box itself, there's an embedded asterisk embedded inside OpenWRT. And if you guys are familiar with OpenWRT, obviously, this would be a no-holds-barred for you to do. And we have actually developed a truly open-source mesh management mapping tool, so you can actually be able to configure and actually administer your network. This graph just shows the amount of internet users in Africa. So where Wireless Dialogue is basically trying to encourage internet usage. As you can see here, 80% of the population are connected, and we're talking about less than 10% of the population. So our business model is to take the McDonald's type model. So effectively, we get local entrepreneurs to actually buy in to the business model. So we give them the servers, we give them training, and we also provide them with support. And they could then set up a locally owned wireless center for the villages. Now, obviously, the cost within that network is free, and we'll go provide gateway services. One of the main things that the profits go back into getting more equipment, getting the villages connected. Now, the beauty of that is decentralized. The communication network is not owned by the government or by the private companies. And obviously, we all know what happened in Egypt. Effectively, there's a kill switch. With this, obviously, with this system, you can't have a kill switch. It's owned by the people and it's controlled by the people. And finally, if you want to go onto the website, villagetelco.org, it's an excellent place for information. And also join the Google groups. So if you're a hacker, as most of you are, you can join in. We have the A2 billion author that monitor the group. We have Steve Song, who's a Shuttleworth fellow. And we also have Electra. She is the author of the Batman Demon. So if you guys are familiar with OpenWRT, you would know that she is a very, very keen developer on mesh technology. And obviously, you can go to Wireless Dialogue and look at our website, or email me for more information. And that's it. Any questions?
How do you measure quality on the network?
The question is, how do you measure quality on the network? One of the main focus is you're talking about quality of service. One of the main focus of this was that to be able to use this, obviously you're sharing bandwidth between voice and data, exactly. But if you think about it, although the wireless infrastructure here in Europe is actually quite congested, in most of those regions there is no wireless network. So effectively you're going to have a single link. Obviously, again, with the benefits of using mesh technologies, that the more nodes you have, the more routing capabilities you're going to have. So the more infrastructure you build, so 50, 100, 500 nodes, the better your network becomes. And obviously, by building on a single routing, rather than congesting the space with multiple routers, every router is actually utilizing the network properly. And obviously, there's actually a new routing algorithm made by Electra called Batman Advanced. Now that's a layer 2 routing algorithm. So it effectively acts as a switch. So it means you can have multiple servers on top of that. Now, basically, it means that you have a huge wireless LAN network that's totally invisible to the user. Thank you.
How you resolve the problem about the hiding nodes?
The hiding nodes.
Yeah.
The question is, how do you resolve the problem with the hiding nodes? I've never come across that problem myself. I think what you find is that it depends on the routing algorithm that you use. If you're going to build a fixed, because most of the time we're going to build a fixed wireless. So if you look at OLSR and if you look at Batman, you have to actually look at what you're building, how you're going to design your network. So it actually comes down to how you design your wireless network initially. So you say, well, if I'm going to have nodes moving around constantly, now which routing algorithm do I use? Which one is more preferred? So I always find that the weakest part of the point is which routing algorithm to use initially, and that mostly solves your problem.
Do you have any relation with the server backbone project?
The question is, do I have relations with the server backbone project? Actually, the server backbone project is a fork of this Village Telco project. Paul Gardner-Stevens, he actually approached the group and said that he wants to explore and extend it. Obviously, being open to what it is, it was welcome. He's actually put in, for those that don't know, the Batphone project actually utilizes embedded access inside an Android phone. So effectively, an Android phone acts as its own telco, router, and access point. So you can make calls within the Village Telco network without incurring any cost to the operator. That's just for those that don't know.
To what extent do you create disconnected networks in the village that have either no uplink to the rest of the road or risk having no uplink to the rest of the road when all the two nodes fall out?
Sorry, can you repeat the question?
To what extent do you in reality create local networks in the village that either have no uplink to the rest of the road or have the risk of having no uplink when only one or two nodes fall out?
The question is, I'm trying to rephrase that into a shorter sentence. the question is, in terms of, in reality, how do you ensure that, do we actually build decentralized and totally unconnected networks which are not connected to the rest of the world? In our experience, we find that most people want to connect to the world. And the biggest problem, which is obviously we can't solve with the villagetelco project, is the fact that the ISP licenses restricts you from actually gatewaying outside. So governments have actually licensed the spectrum specifically for the big telcos. So as a small local IP, you have to basically pay maybe 35,000 to 40,000 per year in license cost. Now, if you approach the Belgium operators in terms of actually having an ISP, it's virtually at no cost. So you can see the imbalance there. So that's a major hurdle for us at the moment. Hopefully, with the coming of fiber broadband across the west coast of Africa, main one, and I think and a few others, we should be able to alleviate that problem. But again, this is not part of this talk, but we're trying to actually build locally owned and locally provided services. So locally designed websites, local servers, everything locally derived for the local languages. So hopefully that problem should be alleviated. Yes, please.
How do you configure IP addresses?
The question is, how do I configure IP address to the mesh node? It's actually very, very basic. The key point is that within 5 clicks, you should be able to configure a mesh potato. So there's actually a guide. If you go to the villagetelco.org, I don't want to go into too much detail here. But effectively, there's a special facility. You can actually FTP into using a crossover cable. Sorry? No, at the moment it's manually, yes. Yes, please.
What do your franchisees charge their customers?
The question is, what do my franchisees, and what do our franchise charge the customers? Now, this is where we use what we call the tiered model. So we provide services to the enterprises, to the huge companies, and them in turn subsidize the price of the equipment going in to the small businesses and to the small entrepreneurs. So obviously it's done by on a local basis. You're not going to charge the same price in South Africa that you would charge somewhere in Niger, for instance, because the income difference are just too great. So you do it by case by case basis. And obviously, if big enterprises that actually want to locate within that region, if they take our services, part of the agreement is that within that mesh network that they create for themselves, they could be able to connect and use a downlink, and then obviously reduce the cost to the small village entrepreneur. Yes, please.
You redesign your hardware for the buffer upload problem, the fact that most wireless devices have large buffers that are not really designed for small packets like.
The question is, have we designed the hardware for that? For basically the limitations that you have of wireless networking. The answer is the only closed proprietary hardware inside the villagetelco is actually an Atheros chip. Unfortunately, it costs about $250,000 to actually get the code within that to actually then modify the blobs, as you say, to actually make the route more efficient. Now, obviously, we're moving on to software-defined radios. I just saw a talk yesterday about FPGAs. Hopefully, once that barrier have been opened up, because at the moment, it's just really literally impossible for us to design your own radio chip. But everything else is open sourced. But the problem is now, to answer your question, is we still have that limitation. Yes. Any more questions? Okay. Thank you.